Okay, so welcome back. Now, in this one here, we have an alternating series. So in this case, we're going to use the absolute value signs. We did not use the absolute value signs in the last two examples because the terms were all non-negative or positive. So, but in this case, since we have this alternating series, we're going to take the absolute value, again, we're going to use, again, the definition of rho, which is the absolute value of the ratio. And then that'll get rid of this piece here. Okay, so again, we're going to define our rho, which is the limit as n approaches infinity of the absolute value of -1 to the n plus 1 times, let's do it this way, times n plus 1 factorial quantity squared over the quantity 2 times n plus 1 quantity factorial, and that's going to be divided by what we have here, which is -1 to the n times n factorial squared over 2n quantity factorial. Now, since we're dealing with absolute value, these are going to go away because, oops, wrong one, sorry. Okay, those are going to go away since it's positive. Okay, in any case, we're going to end up with a -1 on top, but again, because the absolute values we're going to go away, they're going to go away. So we're going to write this as the limit as n approaches infinity, and now we're going to write this as a product. So this is a square, okay, well, let me write it this way. So this is going to be n plus 1 factorial squared over 2 times n plus 1. I'm going to rewrite this as, I'm going to distribute the 2. So that's going to be 2n plus 2. 2n plus 2 factorial, and this is going to be times 2n factorial over n factorial squared. Now, this here, I'm going to rewrite this as 2, because here I got 2n factorial, this is 2n plus 2 factorial, so I can write this as 2n plus 2 times 2n plus 1 times 2n factorial. And then this factorial cancels with that factorial. So then I end up with this. And then I can combine these two as well. So this can equal the limit. Let me simplify this again. The limit as n approaches infinity. So this is going to become n plus 1 factorial over n factorial quantity squared, right? Times 1 over 2n plus 2 times 2n plus 1, right? And now we can cancel this with this, and we'll get n plus 1 squared on the top. So what do we end up with? This equals the limit as n approaches infinity, and our final thing we get is we get n plus 1 quantity squared over 2n plus 2 times 2n plus 1. Now this may not be obvious where this is going. So let's go further. Well, what does this expand into? So this is going to be the limit as n approaches infinity. And so what do we get? We get, on the top we get n squared plus 2n plus 1. And on the bottom, what do we get? We get 4n squared plus 4n plus 1. And so now we can see that this limit as n goes to infinity equals 1/4. And 1/4 is less than 1, and therefore the series converges. And that's it. Have a great day.